Now, the next topic is Fibonaci series, and it is part A, program number 7. Can you please write down this program? To design a program and to display Fibonacci series using recursive function. To write a to design a program and display Fibonacci series using recursive function. This is part A, program number 7. Are you able to see, or it's better to share screen? Are you able to see?
Yes, ma'am.
Yes, ma'am.
Yesterday's program also you wrote in observation, right? This is also program part A, program number 7 to design a program and display Fibonacci series using recursive function call. Okay, so now we will move on to this another example of recursive function called Fibonacci series. So here, you know that it is nothing but a series of numbers. In maths, you might have seen different series of numbers, right? And you'll be getting for many interview questions also, right? Series, and that is a separate section for that itself. So Fibonacci series is a series of numbers in the order 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. It's an infinite series. So the specialty of this series is, except for the first two numbers, all the numbers are got by adding the previous two numbers. So listen here, you know that 0 is not having any previous numbers. So we are leaving 0. And 1 is also not having, the second number is also not having any previous two numbers to add up. So except for these two numbers, if you take any number in the series, that number is got by adding the previous two numbers. For example, if you add 0 plus 1, you will be getting 1. If you add previous two numbers, right? So if you add 1 plus 1, you will be getting 2. If you add 1 plus 2, you will be getting 3. If you add 2 plus 3, you will be getting 5. Likewise, no? 3 plus 5 will be getting 8. Any number in the series is got by adding the previous two numbers. Except for the first two terms of the sequence or the series, every other term is a sum of the previous two terms. So now we will just see the program, how it is being executed. I'll explain with the iteration. Don't copy the program now. So first I need the iteration to be seen in the notebook. Iteration with the numbers, what value we are passing. And then we will write the program. I'll give you time for execution. Don't write now. So what is the name of the function? So this series of Fibonacci series program we are writing with the. Kiran is very busy. Kiran Kumar. Very busy. Kiran, once in a while you come for the class. Kiran, can you answer me? Anyway, you are able to hear me. I know you are in perfect good connection. What is the name of the function over here, and return value, and what are the arguments?
Ma'am?
What is the name of the function? How the function is declared? What function, user-defined function we have in this program? This chapter is about user-defined function, right? So I was teaching till now what is the user-defined function, how to declare, how to call, and how to define. What is the name of the function? Kiran, I am asking you. I am wasting my time. So next week, after this chapter, Kiran, you're answering the chat box, but it's not int. What int? Int is a data type of the return value. What is the name of the function? Where we are declaring, at least you see, where I have declared the function. After this chapter, for your information, like this chapter, I'll be taking a test, online test only. Only 2-3 questions will be there. So using Google form, you have to type in. Okay, and then I will go back to the next, the previous chapter. So after functions, I'll be taking a test for the operators. And so after this class test, like mostly we'll be having the internal test also. They are planning for that. So as soon as we get over this function chapter, we will be having a test. So here Fibo declaration. Now he got the answer. Fibo is a name of the function, and we are declaring it in the declaration section above main. Return data type is integer. The data type of the arguments passed is also integer, right? So now in the main, we are having certain lines to be executed. First, we are locally declaring some variables, and then we are asking the user to enter the length of the series. What do you mean by length of the series? So here, you know that in this series, it's an infinite series. And if you are telling what will be the length of this series, we will be, the length is determined by the number of integers in the series, right? So here you can see 3 plus 3 plus 9. So this series is having 10 numbers. That means length of this Fibonacci series is 10. So, you can have any number of numbers in the series. The next number will be got by adding these two numbers, right? So, in order to limit with the number of numbers, integers in the Fibonacci series, we are asking the user 55. Mehboob had answered. The next number will be 55. So, we are just asking the user what should be the length of the Fibonacci series. What you expect the program to be printed on the display. If you are telling the length of the series should be 5, then it will be printing 0, 1, 1, 2, 3, right? There are 5 numbers in the series, so it will be printing 5, right? 5 numbers in the series. If you are telling for the 8 numbers, means it will be printing up to here. So if the length is entered as 10, it will be printing up to 34, right? 11 means it will be printing one more number. So that means the length of the series is the number of integers to be displayed in the series. So we are asking the user to enter the length of the series so that we can limit it. Otherwise, it will be running as an infinite set of numbers. So the series will be it will be infinite and it will be printing, right? So we are just asking from the user what should be the Fibonacci series of the enter the length of the Fibonacci series. Suppose the user entered 5. The value of n will be 5, right? Value of n will be 5. Now we are printing the Fibonacci series of length. Length instead of this conversion symbol D, it will be printing the value of 5. So we are just giving a heading. The Fibonacci series of length 5 is. After that, we are entering a for loop. So this program is different from the previous 2 or 3 programs, in which here we are recursively calling the function called Fibo, which is our recursive function. Recursive function is Fibo. Fibo we have declared over here. We are calling the Fibo function from the main, and we know that inside Fibo we will be repeatedly calling the Fibo. That I will tell you. But now this program is different from the previous one because here we are using a for loop. Listen here. We are using a for loop in which we will be calling a Fibo. So we are repeatedly calling Fibo in a for loop. So that means if you are asking the length of 5 of the Fibonacci series, it will be calling Fibo 5 times. Are you listening? It will be calling Fibo 5 times. Each time when we call Fibo, it will go to the Fibo function definition and then it will return the value back to the main. So 5 times it will be calling Fibo. 5 times it will be calling Fibo from main. And one more thing is, when you are calling Fibo once, it will be going through the definition of the Fibo. And inside Fibo, as we are making Fibo of I minus 1 plus Fibo of I minus 2, internally it will be making a recursive call. So when we are making internal recursive call, the recursive calls will be returning to the location from where it was called, right? The rule is Fibo, any function when we call, it will return the value to the place from which it was called. Understood? So if I am calling Fibo I minus 2, it will be recursively calling the same function. Again, the value will be returned to this position. Got it? At last, the value after calculating this Fibo of I minus 1 plus Fibo of I minus 2, this value will be returned back to the main. Got it? The last only it will be returning. So we will see how this iteration is working. So we will first substitute the value and see for each value of I how this function is being called. So you know that now we ended. The user want a Fibonacci series of length 5. So we are having a for loop in which I value is starting from 1. And we are expecting that this for loop should be called until it is less than or equal to 5. You know that the series should be 5 means we will be calling Fibo 5 times. So in the first iteration, the value of n is 5. And now we are using a control variable for the for loop, I equal to 1, right? I equal to 1. Now we are checking whether I value is less than or equal to 5. You know, I is equal to 1. So I value or 1 is less than 5. So it will move on to the execution of the for loop. It will come to the printf statement. It will be calling a Fibo or the function from the printf statement. Listen here, we are not calling just like that. Within the printf statement, we are calling Fibo. Understood? So what will be printed over here in place of this conversion symbol? The result of this Fibo of I will be printed over here. We don't know the result of Fibo of I. What will happen? Now the current value of I is 1. It will be calling Fibo of 1. So actual argument is 1. When we call Fibo, the control will be moving from here to here. It will assign the value of 1. The actual argument value will be assigned to the formal argument I equal to 1. And then it will move on to the body of the loop. Now what will be the first line it will execute? If I equal to 1. What is the value of I in this for loop? Tell me. Nas, she has answered. I equal to 1. Why 2? For the I value equal to 1 only, we are calling Fibo of I. So the first value of I is 1. Understood? For this for loop, listen here you see I equal to 1 to I less than or equal to n. So first value of I will be what? I equal to 1 to I less than equal to 5, right? So first value in this iteration will be I equal to 1. Why you told 2? Okay, so here I equal to 1. That time we are calling Fibo of I. So the value of I is 1. So we will assign 1 to this I and we will move on to the body of the loop in which we will be checking if I equal to 1. Yes, I equal to 1. So what it will do? It will be moving on to the next line, return 0. Understood? If I was not equal to 1, it will move to the next line. Now what happened? Here itself it was caught. I is equal to 1. It will return 0. Where it will be returning? Where it will be returning? Because this call came from main, it will return the value 0 to the main itself. Understood? From wherever the call is made to that place, the return value will be moving. So from here, the 0 value will be returned, and instead of this conversion symbol %d, the value of 0 will be printed. So where it will be printing? On the display. So in the display, we will be seeing 0. We will not be moving here. It will be displaying 0, but as the program is not over, we will not be seeing it. Okay, 0 will be there on the display. Now what will happen? As we reach the main, it will again move towards a for loop. Listen here, for loop. In for loop, what will happen? Some of you were explaining during your presentation video. I saw that for loop, how it is working. You didn't understand, I think. When it moves to the for loop, what will happen? Which part will be executed in this? When we have studied that in for loop, there are 3 parts: initialization part, and then checking part, and then the increment or decrement part. So after execution of one iteration of the for loop, it will now move towards the increment of I. it will not move to this initialization. This is initialization, the term meaning is only for the first value, right? So after I equal to 1, it will move towards in the next iteration, it will increment the value of I. So what will be the value of I now? I was 1, now it became 2, right? Now it is taking whether 2 is less than, what is n value? You know, n value is 5. It is not changing. We are accepted from the user. So now I value is 2. So now it will come, it will be checking whether 2 is less than 5. Yes, it is less. So it will come to this line, print the Fibo of 2. Fibo of 2. The current value of I is 2. So what will happen now? It will come to the and assign the value of 2 to the formal argument Fibo. Right? This function is called Fibo, and to the formal value of I, the value of the actual argument 2 is assigned. Right? So now I value is 2 in this body of the function. So now it will be checking whether I is equal to 1. No, it is not equal to 1. Then it will move to the else if part. Else if part, whether I is equal to 2. Yes, it is equal to 2. Then what it will do? It will return 1. It will return 1. Last iteration it was returning 0. Now it is returning 1. Understood? So now as we called, listen here, as we called Fibo from main, as we called Fibo from main, the return value of 1 also will be towards the main. Understood? From Fibo we called, so we are returning back to the, from main we called Fibo, so we are returning the 1 to the main itself, right? So when it reaches here, what will happen? Return 1. Instead of this conversion symbol, it will be printing the value 1. Sorry. So in the display again, now what will happen is it will be printing 1. It will be printing 1. Now what will happen in the next iteration? Now we finished the iteration of 0, iteration of 1 also over. Now I value is incremented to 2, that is also over. Now what we will do in the next iteration? Now we are coming back to the for loop in which the I value will be incremented. So you know that I value was 2. Now the I value will be, I should see this iteration in your notebook. So now I value will be incremented to 3, right? I value is 3 when 3 is less than or equal to, yes, 3 is less than 5. So it will be moving to the printf statement. It will be calling Fibo of 3. Listen, Fibo of 3. So now what will happen? We are calling Fibo with an argument 3. I value is 3. So it will be coming and checking in the body. If I is equal to 1, no, it is not. Else if I is equal to 2, no, it is not equal to 2. Now it will come to the else part, that is the default part, in which it will be returning Fibo of I minus 1 plus Fibo of I minus 2. What is I value? 3. So it will be like 3 minus 1 plus 3 minus 2. If you get the value of 3 minus 1, and if you add with the Fibo of 3 minus 2, you will be getting the value of Fibo of 3. Understood? So in this series, you know that the first two numbers, as I told when I explained, the first two numbers doesn't have any two previous numbers. We will be just printing, just checking if it is first number, then it is 1. If it is the second number, then it is, if it is the first number, it will be 0. If it is the second number, it will be 1, right? After that, the third number is got by adding the previous two, right? And again, the next number will be adding the previous two. So we'll be getting 2. And the next number will be adding the previous 2. So it will be 3, right? So in order to show that after the first two numbers, we are just making it static return. If it is 1, return 0. In all the, in whatever be the Fibonaci series, the numbers, all numbers will be the same itself. But we know that this recursive call can be applied only from the third number in the series, because then only we have this previous two numbers. So we can apply it only if you can have previous two numbers, and if you are applying this adding of previous two numbers to get the current number, this can be recursively called, right? So that's why we are making this recursive call from the third number. Understood? From the third number. So we are here for the first two numbers, we are just returning 0 and 1. Then we are passing I equal to 3, that is the third number. Then only we will be making this recursive call for adding the last two numbers. I minus 1 will be giving you 2. I minus 3 will be giving you 1. So that means we are adding the previous two numbers in the location 1 and 2. Right? So here, as we had already displayed with the return of 0, the first digit will be 0, the second was 1. Now, as we are moving towards I equal to 3, it will be returning this value. So we thought that if we go of 3 minus 1 plus added with the Fibo of 3 minus 2, if we are getting, then we can return that to mean. So now we are making an attempt to find the value of Fibo of 3 minus 1. What is Fibo of 3 minus 1? Fibo of 3 minus 1 is 2, right? Fibo of 2 plus Fibo of 3 minus 2 is what? Fibo of 1, right? So we will be substituting and we will be subtracting and substituting Fibo of 2 plus Fibo of 1. You know that Fibo of 2, when we are calling from this return, we don't know the value of Fibo of 2. What will happen now? When we are calling a function, it will move towards the function header, Fibo of 2. Now what will happen? Instead of this I value, it will be substituting the I value as 2. Now it will come and check over here. I value is 2. So if I is equal to 1, it will move towards the else part. As I value is equal to 2, it will return 1. Now tell me to which location this will be returning. To which location? Is it towards the main or towards this function call? Value of 1 will be returned to the main. So the last two cases, it was returning 0 and 1 towards the main. But now when we are calling Fibo of 3, inside we saw that we are returning Fibo of 2 plus Fibo of 1. When we call Fibo of 2 from here, the value of this, when we are finding Fibo of 2, the value will be returned to the main or to this function call. Tell me, can anybody answer? To the function call. Nirma has answered. August, we also answered. Fibo of I minus 1. Mehboob has answered. To the function call, not towards the mean. Janani also answered. So now we are returning this 1 not towards the main. We are returning it where we are returning to the function call. So here you know we were calling the Fibo of 2 from here means it will be returning the value of 1 towards this function call. So it will be returning 1 here. Now it will be putting this plus symbol. Now it will be calling Fibo of 1. Fibo of 1. So what will happen? Instead of this 2, it will be assigning the value of 1. Within the function, we are recursively calling, right? So we are substituting that value as 1. Now it will be checking again. If I equal to 1, return 0. Now also this 0 value will be returning to the function call itself, right? So it will be substituting the value of 0 instead of Fibo of 1. Right? Now what will happen? 1 plus 1. 1 plus 1 is what? 1. So instead of this portion, it will be substituting as 1. Return 1. Now this return, where it will be returning? Can anybody answer in the chat box? This return, where it will be returning? You should remember that whenever a function is called, internally recursive calls are making means it will be returning back to that function call. But when we are reaching after final substitution, Mehboob has answered, this will be returning back to the main. Understood? This return is back to the main. Karthik also answered. So this will be returning back to the main. Here when we make internal calls or recursive calls, it will be returning to this location within the function. But when we are calling it from the main or this call, it started from here means after substituting these values, the value will be returning back to the main. So we found the value of Fibo of 3, right? So we had printed already 0 and 1. Now we got 0 plus 1 as 1. So we'll be printing or whatever value we return back to the main is 1. So it will be printing as 1. Now what happened? Again, we are going to, this should be there in your notebook. So what will be happening now? More than the program, I need these iterations. So now we have incremented the value. It was 3. Now we are again incrementing the value. Now the value of I will be 4, right? So we are checking whether 4 is less than or equal to n. Yes, it is less. So it will be calling Fibo of 4. Now what will happen? It will not go to this line or this line. It will go directly to this line. So it will be substituting Fibo of 4 minus 1. All of you do in your notebook. Here it will be 4 minus 2. Right? So this will be calling what? Fibo of 3 plus Fibo of 2. Right? So this is an internal call. So this will be what? It will be making a recursive call to Fibo of 3. You know that Fibo of 3 again, it has to make one more recursive call. Right? So like last step, it will be recursively calling Fibo of 2 plus Fibo of 1. So how to find the value of Fibo of 3? You know that Fibo of 3 is again, it will come to this line and it will be recursively calling Fibo of 3 minus 1, right? Fibo of 3 minus 1 is what? 3 minus 1 is Fibo of 2 plus Fibo of 2. Here it will be Fibo of 1, right? So this part alone you will be getting if you substitute this value. And for Fibo of 2, what you have to do? So this part, if you want to get, you have to do as Fibo of 0 plus Fibo of 1 plus Fibo of 0. Understood? So this becomes a recursive call. Within one call, again we are calling one more call. Fibo of 1 plus Fibo of 0. Understood? So this becomes a recursive call. So whatever values we got for Fibo of 2 plus Fibo of 1, you know that Fibo of 2, what will be Fibo of 2? It will be returning 1. So you will substitute 1 plus Fibo of 1 is what? Fibo of 1 will be returning 0. It will be substituted here. So it will be returning like 1 plus 1 will be 1. So in place of this Fibo of 3, we will substitute as 1 plus what is Fibo of 2? Fibo of 2 is Fibo of 1 plus Fibo of 0. Right? So you know that Fibo of 2, what is Fibo of 2? Fibo of 2, if you are passing, it will come over here. I is not equal to 1. If I equal to 2, return 1. So this part will be 1. Right? So this will be, instead of Fibo of 2, we will be getting 1. Instead of 3, Fibo of 3 will be getting 1. So 1 plus 1 is what? 2. So after this, no, for Fibo of 4, we will be returning 2 to the main. Right? So we will be printing what? We will be printing 2. Now what is the next number? Next number, when I value is incremented, you will be making the value of I as what? I will be 5. So this citation, it should be there in your notebook. Don't tell me that you didn't. If you have any doubt, you can ask now itself. Nas, Karthik, Pradeep, anyone? So here, what is the next iteration value? So can anybody tell? Unmute and speak. What will be the value of I now? I value will be 5 now. So 5, whether it is less than or equal to n. You know that 5 is equal to 5, right? So what will happen? Fibo of 5. Fibo of 5. We are calling with the Fibo of 5. So now this I value will be assigned as 5. Directly, you know that I is not equal to 1, I is not equal to 2. It will move to this line. So what will happen now? It will be returning, or it will be calling internally a recursive call of Fibo of, what are the two first calls? Tell me. Fibo of 5 minus 1 is, here you are substituting with 5. Listen, 5 minus, so it will be Fibo of 4 plus Fibo of 3. Good. Somebody, if you are telling that it is, I feel you are listening. So it is Fibo of 3. Now what will happen? So this part alone we will take Fibo of 4. Now what will happen? Instead of this 5, it will be substituting as 4. Now tell me what will happen. This part alone, it will come again to this Fibo. It will check I equal to 1. No. I equal to 2. No. So it will again come to this line. And now the current value of I is 4. So what will happen now? Internally, what this will be calling? Tell me. Fibo of 4 minus 1, right? Internally, it will be calling Fibo of 4 minus 1 is Fibo of 3. To substitute or to get the value of Fibo of 4, you have to add Fibo of 3 plus Fibo of 2. Understood? I minus 1 is what? 4 minus 1 is 3. Fibo of 4 minus 1. This is 4 minus 2. That is Fibo of 2. Right? So this part, if you want to get the value, you should be finding the value of Fibo of 3 plus Fibo of 2. Now again, we will be calling Fibo of 3. So instead of I value 4, now it will be passing 3. So it will come and check whether I value is equal to 1. No, I value is not equal to 2. So it will come to this line, right? So now instead of 4, we will be substituting what? We will be substituting the value of 3, right? So here now it is 3. So how we will be getting the value of Fibo of 3? Fibo of 3 minus 1. So to solve this part, you should be calling Fibo of, if board was there, it was easy to write. Fibo of 3 minus 1. What is 3 minus 1? It is 2, right? I should be seeing like this lines in your notebook. Not handwriting. I can't write here. That is Fibo of 2 plus Fibo of 1, right? So this value will be Fibo of 3. If you want to get, you should substitute the value of Fibo of 2 plus Fibo of 1. Understood? So now again this Fibo of 2 we will call. Now instead of 3, the value of I is 2. So it will come and check. I is equal to 1. No. I equal to 2. Yes, it is returning what? It is returning 1. Understood? So where it will be returning? It will be returning to the previous call where it was called here Fibo of 2. So we got the value of Fibo of 2. We are going to substitute 1. Understood? So now this part is over. The right part is Fibo of 1. What is Fibo of 1? Fibo of 1 is, it will be, when it called, it will be coming over here. This will be substituted with 1. It will be returning 0. It will be returning 0 to this location. It will be 1 plus 1. So now you got the value of Fibo of 3 as 1. So what I'm going to do, I'm going to substitute instead of this part. I got the value as 1, right? So this I'm going to substitute the value as 1. So here Fibo of 3 is 1 plus, again we are calling Fibo of 2, right? So now the new value of I is 2. We will check I equal to 1. No. I equal to 2. Yes. Return 1. So it will be returning 1 to this location. Understood? So now it is 1 plus 1. 1 plus 1 is 2. So after solving Fibo of 3 plus Fibo of 2, we got the value as 2. Right? Now I'm going to substitute in the previous function call. Instead of this part, I'm going to substitute. We got the value of Fibo of 3 plus Fibo of 2 as 2. So we are going to substitute the value of 2 in the previous call. So this part I got it as 2 plus Fibo of 3. So what is new value of I? New value of I is 3. So when it comes over here, I equal to 1, return I equal to 2. No, it is coming to I equal to 3, right? So it will come to this part, Fibo of 3 minus 1 plus 3 minus 2. So in order to solve Fibo of 3, you should find the value of Fibo of 2 plus Fibo of 1. Are you able to understand? All are listening to something else. Fibo of 1, right? So Fibo of 2, when we call again, it will come over here. The value of Fibo of 2 is what? 1. So it will substitute 1 plus Fibo of 1 is what? Fibo of 1, it will be returning 0. So this part I got the value as 1 plus 1 as 1. So what I will do now? So instead of this part, listen here, I got Fibo of 3 as Fibo of 2 plus Fibo of 1. That is 1 plus 0. 1 plus 0 is what? 1. So instead of Fibo of 3, I'll be writing 1. So now I got Fibo of, instead of Fibo of 4, I wrote 2. Fibo of 3, I got the value as 1. 2 plus 1 will be 3. Now what will happen? This is the value. The 3 is the value which will be returned back to the main when Fibo of 5 is called. All other returns were happening within the function, recursive function. So now we are returning 3 to Fibo. So when we are returning 3 to Fibo, it will be printing 3. So now it will again move back to the for loop and it will be incrementing the value of I to 6. You know that I value 6 means it is not less than, it is not equal to 5. It will come out of the for loop. It will come to this get ch and we will be able to see the output on the screen as 0, 1, this value of 0, 1, 1, 2, 3 on the screen. So this is the execution of the program. If you have any doubts, you can ask me. This iterations and any iteration, if you want me to repeat also, I can repeat.